Hello, my name is Tom Jr. I'm the lead programmer here at ADC, and this is a quick operation demo of MechLab, our new mechanical test software used with our new line of compression testers. As always, you can find more information at our website, automateddesign.com. So I'm just going to take you through starting up the software and basically the everyday usage of the software. There will be more details in the manual, and I'll also be presenting a operation or setup manual to accompany this one. But for day-to-day operations, I thought I'd just focus on that, keep it simple. I'm going to start up the software. And what we see here is just the software going out and talking to the machine. It has to go and configure the components, so there is a little bit of a startup time. The box you saw can be hidden from view, so you can do things like change settings or load configurations while it's doing that. It won't affect the operation of the machine. If you hide it, it's still going to try and connect. Can't hurt it by hiding it. This is the main control screen. Most of our work happens here. I'm going to take you from left to right. This is the dashboard. We have the position display, that's live. We have the live load display. This is the panic button. If for some reason you need to issue an immediate stop, just click that panic button. It will shut down all subsystems and stop the machine. To recover from a panic, you reset the faults or return the system home. These are test result indicators just for the last test you used. This is a cycle count every time you run a test. Helps you keep track. You can clear the data with this button. Deflection, diameter, maximum load, and cycle time. This is the data display table. As you keep testing, it will fill in with the data. You can export these results using this button here. This indicator tells you that you're ready to test, which means you've homed and you've loaded a test configuration which you've activated. If you've homed, this light will be green. If you've activated a test configuration, this light will be green. If this is green, you're ready to test. You also won't be able to test if there's a fault, which is indicated here. This is your run button, and you're going to spend most of your time clicking this. When you have your configuration loaded, you'll click the run button, and it will do the complete test that you've set up. We go to different areas of the program by using the tab display here. Instead of hiding everything in menus, we simply make it easy to display all the information you need and group it into tabs. Manual control is mainly for servicing the system. You can enable manual control, enable the drive and jog it up and down. There's no practical use for this in terms of testing, but if you feel the need to service or test out the mechanical system, it may come in handy, and certainly it's a good startup test. Most people won't ever need to use this tab. You may be asked to use it by an ADC technical support representative. Auto will not run when manual is enabled. If you try to run it when manual is enabled, it will give you a message. This box must be unchecked for auto to run. Test configuration is where we set up the parameters for our test. Every test consists of a preload weight, a preload dwell, which you can turn on and off. You select whether you crush to weight or crush to distance, and then you define that weight or that distance in the units you're set up for. You can dwell after the crush has completed, the crush portion of the test. These times are defined in seconds. You can define them out to 4 decimal places. The system will try to be that precise. New configuration allows us to create a new configuration. When we do so, we're only working on the screen. It cancels out whatever configuration we had previously loaded and deactivates the test, but it does not delete. It simply gives you a blank template from which to start from. The defaults are put in, and the defaults are based on the most common settings used on the type of system you've ordered for golf compression, for example. These are the most common settings we see. Open configuration allows you to open a pre-made configuration. Any configuration you make can be preloaded. This allows setup time, and after you've developed the methodology of a test, to be loaded within seconds. Simply navigate to where you're storing these files, load them up, and you're ready to go once you activate the configuration. We tell you the time you activated just so you can keep track whether or not you've made a change and reactivated. Save configuration allows you to save changes. You can make edits to the test configuration and activate them. They will not be saved, but they will take immediate effect on the operation of the system. As you can see, I've brought it back from where I had it saved at, even though I activated it. So activation is a non-destructive button, but it is required to operate the machine. Save configuration does what it says it does. Copy configuration allows you to make a new configuration based off of the one you currently have loaded. So let's say that I have a standard golf ball test, but I want to have one that goes to more force. Copy the configuration. I'm now working off of the new configuration. Change my force to 300. Save it. And now I have a high force golf ball configuration. When I want to go back to the old one, there it is. Delete configuration also does what it says it does. You can also delete configurations through the regular Windows Explorer. It deletes the configuration you have opened currently. It does not open a dialog box for you to select it. That's what Windows Explorer is for. Once it's gone forever, so use it with care. In this case, I'm not going to delete standard golf ball. But if I wanted to get rid of high force golf ball, I could simply come here, click delete, and it's gone. I'm now going to go back to standard golf ball, and I'm going to activate the configuration, and that places it into memory in the program. It makes it, puts it into the control system, and those are the parameters that are going to run. So in this case, I'm going to have a preload weight of ½ pound. Now notice here everything is negative. This is compression, which load cells treat as negative. So we have you enter the data in as negative. You can't enter in a positive number. You can't see me typing, but I'm actually trying to do so, and it won't let me. You must start out with a negative number. Preload dwell is in seconds, and here activates it. If I uncheck this box, there will be no pause after we reach the preload weight. Typically, people will have a pause there, and we activate it with that checkbox. Crush to weight means that the ball will be crushed from the preload weight to the final weight, and the position will be recorded. If we crush to distance, we do the opposite. We crush to the distance and record the weight. In both tests, we get both of those data items. It's just the way we decide when we stop. Crush dwell is the pause after we reach this distance. The usual is 1 second. We can turn it off and come right back down if we like. So again, for good measure, I'm going to activate the configuration, and then we return to the main control tab. Now I have to go home before I can run a test, because in this case I'm near the home position. Nothing moved. It has been set as home. When I home it, it tears our load cell, which is to say it subtracts out the additional weight beyond 0 it has. Notice that our load cell is always bouncing. Every load cell has a minimum resolution. In this case, the one I'm using has a resolution of ± ½ pound. So I've activated my test. I'm home and I'm ready to test. I've put a generic golf ball into the system, and we are going to run it. I click run. We see that my cycle is running. I'm moving. There's my force. And there is the results. There's my deflection. There's a measurement of the ball I have. Maximum load that was recorded. The cycle time. And I also give a timestamp that is useful when you're looking back over the data. We're going to run a couple more tests so I can show exporting data. I'm going to change the ball for fun. All the results you see here, by the way, are run on very random and very poor quality objects, and so all of the settings are basically for show, or I'm not sorry, all of the results are for show. Okay, we have a couple lines of data. We want to export it. I have a data folder I use. And we've exported it to a comma-separated value file. Comma-separated value files are very common and can be opened natively in any text viewer and treated just like a spreadsheet in Excel. So they're easy to use with, and they are ubiquitous and are not software dependent, which is why we use them. When we're done with the software, we can simply close the program by File Exit, or just by closing the window. The system will be completely shut down. Are you sure? If you say no, nothing happens. If you say exit, the system will shut down. This concludes the first operational training video for this system. Again, if there are any questions or interest in more information, please be sure to contact us and visit us at automateddesign.com. Thank you.